Hello everybody, this is Mr. Longo, and in this video we are going to cover the distance formula. Now, just so you know, the distance formula is used to find the length of a segment, and to do that, that's finding the distance between 2 points, and those 2 points would be the starting point and the ending point. Now, I know segments have 2 endpoints, which is fine. Just so you know, it's pretty much like taking a ruler and measuring, but we're going to be talking about this on the coordinate plane. So to find the distance between 2 points, there's actually 2 different ways you can do it. You can use the distance formula, which is what this video is all about. But there's also a shortcut if you're more familiar with it. You can do it that way as well. So just to show you, the distance formula is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now x2 and x1, those are talking about your different x coordinates from your original points. y2 and y1 are from also the same thing. But you have to take it into certain points, as in which one's your first point, which one's your second. Now, to be honest, that doesn't matter. You can call point A coordinate 1 and point B coordinate 2. Or you can switch them up. The order doesn't matter as long as you're consistent. So we can see that this would be x1, y1, and this would be x2, y2, because of course our coordinates are x, y. So now all we have to do is use the given formula. So we take what we have, and we have the square root of x2, we know is 5, minus x1 is 0, quantity squared, plus y2 is 1 minus y1 is 3. And then you always want to make sure you wrap things in parentheses and square them, so we're a little bit more careful. 5 minus 0 is 5, so this is going to become 5 squared, plus 1 minus 3 is a negative 2 squared. And the reason mine are still in parentheses is because if you use a calculator, if you type negative 2 squared, it's going to tell you negative 4. But if you type the negative 2 in parentheses and square it like I have written, it'll give you a positive 4. That's where a lot of mistakes are going to happen, is with the negatives. So 5 squared is 25, plus negative 2 squared is 4. So we get an answer of the square root of 29. Now that is our exact answer. So if you are asked for an exact answer, you want to leave it as the square root of 29 because square root of 29 is not a perfect number. But we could say that the square root of 29 is also equal to, and this would be our approximate answer, 5.385. That's good enough. It actually goes on like 1, 6, blah, 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 blah. But that would be our approximate answer. And that's because we had to round it. Rounding is not an exact number, okay? So that's just some little word of caution. Make sure you read the directions to find out if we're doing exact or approximate. So the next way we can do it is something that you already know. And it's a squared plus b squared is equal to c squared, and that is known as the Pythagorean Theorem. So the Pythagorean Theorem is pretty much used for right triangles. Now, the best way to do that would be to graph our coordinates. So we have a, which is 0, 3, and we have b, which is 5, 1. And we are going to look for the distance between those, but in order to do that, we need to know what the 2 legs are. So we have a vertical leg and a horizontal leg that make a right triangle. And all you need to do is figure out how far up this little piece goes. So it goes up 2. So A would be 2. So we have 2 squared plus. And our horizontal piece, we go from 0 all the way to 5, has a horizontal length of 5. So plus 5 squared is equal to c squared. And now we're just going to go solve for c, and you're going to find that we're going to get the exact same answer, because you should already see we have a 5 squared and a 2 squared. So 2 squared is 4 plus 5 squared is 25 equals c squared. 4 plus 25 is still 29 equals c squared. To get rid of the square symbol, you have to square root both sides. So we're going to square root c squared and square root 29, and you will see that we are still going to get c is equal to the square root of 29, which is also known as 5.385. Okay, so there's two different ways to do it. The original way, as the video suggests, is the distance formula. And the second method is the Pythagorean Theorem, if you would like to sketch it out on a graph. Okay, so that's me stepping you through this guy. Two different methods. Here's an example for you to try on your own. What I would like you to do is pause the video, give it a shot, and once you are ready to go, click play and see if you got the right answer. Giddy up! Okay, so we had to find CD. Now, it really didn't matter which way you did it, but since this video is about the distance formula, I'm going to do it using the distance formula so you have more practice with it. So the first thing we need to do is label our points. We have x1 and y1. We have x2 and y2. So we're going to take our distance formula here, and we should have 4 minus a negative 2, quantity squared, plus, and then we have a negative 5 minus 3 squared. Make sure you're always careful with your negatives. 4 minus a negative 2 is going to give us 6 squared, plus negative 5 minus 3 is a negative 8 squared. So that's going to give us 36 plus 64, which is 100. And now we know that the square root of 100 is 10. So there's no need for a square root of 100. It's a perfect square, so we can just write it as 10. Okay? So that is what you should have got if you tried that guy on your own. All right? That's it for this video on the distance formula. This is Longo, and I'm out. See you, bye.